So let us now discuss how can we solve this problem. Minimum operations to make the integer 0. So we are given with two integers num1 and num2. In one operation, you can choose integer I in the range 0 to 60 and subtract 2 power I plus num2 from num1, right? Return the integer denoting the minimum number of operations needed to make num1 equal to 0. Okay, let me refresh it, right? So return the integer denoting the minimum number of operations needed to make num1 equal to 0. So we need to make this num1 as 0. How? We are removing, what are we removing from this num1? So we are just removing from this num1 minus subtract 2 power I plus num2, subtract 2 power I plus num2. This is the first operation and this is the second operation, and this will be the third, and consecutively this will be my I1, I2, and so on ik plus num2. So here num2 is for only one time. When I2, it is for two times. When ik, num2 will be for k times, right? Okay. Now let us write it as num1 minus 2 power I1 plus num2 minus 2 power I2 plus num2, and so on, minus 2 power ik plus num2. Now, if you see, num2 is repeating for k times. So let me write it as num1 minus 2 power I1 plus 2 power I2 plus and so on 2 power ik and minus k into num2, which is nothing but 0. We are just making it as 0. 0 is equal to number minus all this. Now what I'll do, I'll just send it to the left side, or let me write it on the left. So num1 minus k into num2 is equal to 2 power I1 plus 2 power I2 and so on 2 power ik. Okay. So this, let me rename it as S. So S is nothing but 2 power I1 plus 2 power I2 plus and so on 2 power ik. So it has made it as so simple, so that we just need this S should be represented as sum of powers of 2, if I am not wrong, right? So sum of powers of 2, so S should be represented as sum of powers of 2. But how do I get this S? By only taking k, but k will go till 60. Why I am saying it? K is nothing but number of operations, right? Let me tell you, k would be going till 60. Why? Because this one, this value will not go beyond 10 power 18, which is nothing but 2 power 60. Now why I am saying this as 2 power 60, which I can get it by this sum of powers of 2. So it will not go beyond 10 power 18, which is nothing but 2 power 60. So what I'll do is I'll write a for loop where k will be starting from 1. We cannot take 0 operations. I am not taking this k as something like another number. K is nothing but the number of operations itself. So k is equal to 1 and k is going till less than or equal to 60k plus plus. There is something like S is equal to num1 minus k into num2. I need to know whether S can be represented in sum of powers of 2. Let me write it over here. So can S be represented in sum of powers of 2? Sum of powers of 2. If so, If so, return k there itself. I'm going from smaller number to bigger number for this k. So I need the minimum number of operations. So if I get to know that s can be represented in sum of powers of 2, if so, return k there itself. So I got the intuition, but let me take an example here so that you can understand what are the conditions which we can include so that S can be represented in sum of powers of 2. Let us imagine k is equal to 3 and s is equal to 4. How can we represent s in binary representation? 1, 0, 0. How many set bits I have? Set bits is nothing but the power of 2, right? Set bits I have only 1. But k is equal to 3. If let us take set bits are 3, something like 111, which is nothing but 7, s is equal to 7 and k is equal to 3, then it is so simple that we can add 2 power 0 plus 2 power 1 plus 2 power 2 is nothing but the sum of powers of 2, which will result in k, which will give us k is equal to 3, and also sum of 7, s of 7. So it is not something like it, but we can we represent 4 as sum of powers of 2. I need 2 power something plus 2 power something plus 2 power something for 3 times. K is equal to 3, as k is equal to 3. I'll tell you. 2 power 1, 2 power 0, and then 2 power 0. 2 power 1 is 2 plus 2 power 0 is 1. 2 power 0 is 1 again, which is 4 is nothing but s. So the number of set bits of S is less than or equal to K, then we can include this. But there is another condition which we need to specify. But before that, you might ask me why you aren't including set bits. If set bits of S is greater than K, can't we get uh, sum of s? So what I said, I need s to be represented is nothing but sum of powers of 2. How many I need? Let us take uh, s is equal to 15 and set bits of s is nothing but 4. Now k is just 3. I'm saying that this cannot be, will not work. So s is equal to 15. 15 itself need 4, 4 powers of 2. I'll tell you, 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3. 8 plus 8 plus 4 plus 2 plus 1 is nothing but 15. But we are saying that we need to represent with only 3. As k is equal to 3, we need only 3 powers of 2 and it should get to s. So it is not possible. So only when set bits of s is less than or equal to k, then only we can represent. There is another thing. S is something like, let me take let me take s as something like 9. Now if you see, s is 9 and k, let me take it as 10. Now there is a problem. S is 9 can be represented as how many times? Maximum. Let us say. Let us start with the minimum one first. 1, 2, 4, 8. Only 2. We can represent with only 2. This is the minimum. But what is the maximum? Sum of powers of 2. I am not just asking that 2 power 0 plus 2 power 3 is 9. 1 plus 8 is 9. But 2 power 0 plus 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 2 power 0 is equal to 9. How many powers of 2 I took? Only 9, right? There is nothing like 2 power something which will give you 0. 2 power 0 itself is 1. So 1 for how many times? 9 times is giving me 9, right? So S is just 9. But K, what you are asking, you need to represent S equal to 9 should be represented in sum of powers of 2. How many powers of 2 are we taking? 10. But the maximum I can get, the maximum number of powers of 2 I can take to represent S is just S itself, right? S itself is the maximum powers of 2 I can take to represent S. So S should be less than or equal to K. Now, this is the second condition. What is the previous condition which I have included? Set bits of s should be less than or equal to k, right? Am I right? Let us see. S is less than or equal to k. No, sorry for this mistake. S should be, this is the wrong condition, right? S is 9 but k is 10, so s should be greater than or equal to k. Then only we can represent s as the sum of powers of 2. These powers of 2 are taken for k times. Okay, so set bits of s should be less than or equal to k, s should be greater than or equal to k, then we can return k there itself. But there is another condition. What if the s becomes negative? Then we need to just skip that part. So let me write the algorithm here itself, just the pseudocode. So if it is less than or equal to 0, then continue. Now, if, how can we write the set bits? How can we know the set bits in C++? It is nothing but built-in pop count uh, of s. Set bits of s should be less than or equal to k, and s should be greater than or equal to k. Then return k there itself. Now, if not, I will return -1 at the end. This is how you solve this problem. If you like this video, do share to your friends and do subscribe to my channel. Thanks for watching this video.